All right, we're going to look at solving quadratic equations. Um, if you want a quick refresher, you can factor each of these, but since we do factoring later on in the notes, I'm going to skip those for now, but they are done on the answer key that is posted. So for the two up here, our GCF was 1 and our A value is 1. So our A is the number in front of our squared term, so there's a 1 there. That makes it easier to factor. Sometimes, though, your A is not 1, and we might have a GCF, and we want to be able to factor out our GCF to make our polynomial easier to work with. We also want to take into account the signs of our constants. So if it's positive or negative, that's going to affect the numbers that we want for when we factor. So when we factor with the GCF, we want to determine if there is one. GCF stands for our greatest common factor. And if there is a GCF other than 1, we want to divide each term by that GCF and write what is left over on the inside of parentheses. If our first term is negative, then our GCF will also be negative. So we're going to go through two examples of just factoring out the GCF. So I'm going to start with this one. I want to look at each term and think what they have in common. So something I first notice is my A value is positive, so I know my GCF will also be positive. I have 9, 12, and negative 36. Right now, I'm not worried about the signs. I just want to see what they have in common. And I know I can divide all of them by 3. And then I want to look at my variables, and this last term doesn't have any variables, so they don't have that in common for me to factor out. So just the 3. So I'm going to divide my first term by 3. 9x squared divided by 3 is going to be 3x squared, and I write what's left over on the inside of parentheses. This 3 out here is our GCF. That's what we're dividing by each term. My second term, when I divide by 3, will give me a positive 4x. And then my last term when I divide by 3 is going to give me negative 12. And then I'm done with this one. It just said to factor out the GCF, not to factor it completely, so that's my final answer. For the one on the right, something I notice is my A value, my first term is negative, so I know my GCF will also be negative. I also notice that I have x's in all of my terms as well. So not only will I have a number that's a GCF, but some variable or variables as well. So when I look at 2, 6, and 14, I know I can divide all of them by 2. And we said our GCF is negative. And then I look at x to the 4th, x to the 3rd, and x squared. Well, I can take 2 x's from each of them, so that's going to be x squared. This is my GCF. I put this out in front, so I'm going to divide each term by negative 2x squared. When I divide by first term, I'm left with x squared because my negative 2's will cancel, leaving me with a positive 1, which I'm not going to write down. And then x to the 4th, I took x squared out, so I still have x squared. Then I can divide this by my GCF. Well, positive 6 divided by negative 2 is negative 3. I had x cubed. I'm dividing by x squared, so I have 1x left over. Then my last term, I'm also dividing by negative 2x squared. Positive 14 divided by negative 2 is negative 7. X squared divided by x squared means those are gone, and I am done. If you want to pause the video and try the U-tries, I would recommend you doing that, and I'm going to do them pretty quickly. So I got a GCF of positive 2 for this one, and this is what I have left over when I divide each term by 2. I got a GCF of 4 for this one, and this is what I have left when I divide each term by 4. You'll notice I didn't actually write what I'm dividing under each term because for me, I don't need to. If you you still need to do this, that's great. Do that every time. If you don't need to do it, that's fine too. All right, we're going to flip our page. So now we're going to fully factor something. If you need the steps, they're up there, but we have been factoring for years now, so we might not need them, but it's always a good reminder. We want to make sure that we're paying attention to the directions, because if you are asked for the x-intercepts or the roots or the zeros, we're going to add another one, or solutions, then you're going to use the zero product property and set each part equal to 0 and actually solve for those intercepts, those x-intercepts. These are all interchangeable, so I could ask for any of those. They all mean x-intercepts. So with this first one here, I want to look at if I have a GCF other than 1. So I have 4, 40, and 96. Well, I can divide all of those by 4, so that's what I'm going to do to start. So I'm going to pull out my 4, and I can do that part in my head, but if I wanted to double check, I would divide each of them by 4 and make sure that I got -10 and +40 or +24. Then I want to find numbers that multiply to a +24 that add up to -10. Since I'm multiplying to a positive, my factors have to be the same sign, so they either can be both positive or both negative. So I can have +1 and +24, -1, -24. And I'm going to make my entire list. If you are to the point where you don't need to make the list and can see it right away, that is fantastic. Some of us are not. So those are all of my numbers that if I multiply them would give me a +24. So of the pair, I want the pair that adds up to a -10, and that's going to be the very last one that I wrote down here. So for my final answer, I don't want to forget about my GCF of 4. That goes out in front. Then I have my variable with my -4 or -4, and then my other parenthesis, my variable again, and my other factor, and then this is my final answer. This is my factored form for that trinomial. For the one on the right, I notice my first term here is negative, so I know my GCF will also be negative. There is an invisible 1 here, so I have 1, 8, and 7. Well, since this is 1, my GCF has to be 1, so I know my GCF is -1, and then I look at my variables, and I can pull 2 D's from each term. So my GCF is going to be -D squared or -1D squared. I want to be really careful when I'm dividing each term by my GCF, because if I'm dividing by negative, all my signs are going to change. So I am left with D squared. +8 divided by -1 is going to be -8. And then I still have 1D because I had 3. I took 2 out. I have 1 left. And then -7 divided by -1 would be a +7 here. I had D squared. I pulled D squared out, so I don't have any left. I close my parentheses. So I want numbers that multiply to +7 that add up to -8. Well, that's nice because 7 only has one pair of numbers, 1 and 7. So I can do +1, +7, or -1, -7. But if I'm adding them up to -8, I want the negative version. So I put one factor in each, make sure I have my GCF out in front, and I'm done. So again, I'm going to let you pause the video if you'd like to try the U-tries, and I will do them quickly here. All right, so for the one on the left, I got a GCF of 3, so I factored that out first. I'm left with those parentheses. For the second one, I have a GCF of negative 2a, and I would accept either of these. They do mean the same mathematically because if I have a plus 5 times a plus 5, the same thing, it's being multiplied by itself, and there's 2 of them, so that's the same as doing a plus 5 inside parentheses squared. Whatever you are comfortable with, I will accept, but I'm going to include both on the key here. For the ones at the bottom, if we are asked to factor it and identify the roots we actually want to solve, these are also different because I don't have it equal to 0 yet, so I first have to make sure it is set equal to 0 before I do anything else. So I have n squared plus 7n plus 10 equals 0, and then I can go from there. So my GCF, if I look at my 3 terms, would just be 1. So I don't need to divide everything by 1 because that's going to keep it all the same. So 2 numbers that multiply to a positive 10 that add up to a positive 7 is going to be positive 2 and positive 5. Now, since it actually says to identify the roots, I need to set these each equal to 0 and solve. So I'm going to take my n plus 2 equals 0 and then n plus 5 equals 0. If I solve the equation on the left, I would get n equals negative 2. And then the equation on the right, I would get n equals negative 5. That's a little stuck there. There you go. So for the one on the right, I'm going to start with the same thing. I always have to have it equal to 0 first. So I'm going to subtract 6 from both sides. So x squared plus 3x minus 18 equals 0 because it was negative 12 minus 6. So I want numbers that multiply to negative 18 that add up to a positive 3 because my GCF again is just 1. So I don't need to factor that out. And I know 3 times 6 is 18. If it's negative 18, one of them has to be negative. So I'm going to make my 3 negative because positive 6 plus negative 3 would give me a positive 3 here. So I have x plus 6 and x minus 3. I'm going to break each part, set them equal to 0. Oops, I skipped ahead there. Make that a minus 3 equals 0. I'm sorry. So we should get negative 6 and positive 3 for our final answers. These are the roots. This is where it would cross the x-axis if we were to graph it. All right, we're going to flip our page. So now we're going to look at factoring when a is not 1. So this is where it gets a little bit more complicated. If you are solely just solving a quadratic, I very much would rather use the quadratic formula. However, this is really useful when you are rationalizing denominators, canceling things out, simplifying fractions with expressions. You will have to factor for that. So we're going to go through how to factor if a is not 1, especially if we factor out the GCF and the a value is still not 1. So for this first one here, I have y equals, so we can say that that's a 0, and I have 4x squared minus 19x plus 12. So I'm going to look for my GCF, and because of the 19, I actually can't divide them all by anything other than 1. So to factor this, what I need to do is multiply my a and my c, and I'm going to label them here. So a, b, and c. C is always my constant. A is the term in front of my variable being squared, and then b is the coefficient in front of the variable raised to a power of 1. So I want to make my t-chart. I want numbers that multiply to whatever a times c is and adds up to b. So when I multiply a times c, I have 4 times 12, and that's going to give me 48. So I want factors of 48 that are going to add up to a negative 19. Now, I don't know this one just by looking at it, so I do have to make my list. So I can have 1 and 48, negative 1 and negative 48. I can have 2 and 24, negative 2, negative 24. 3 and 16, negative 3, negative 16. 4 and 12, negative 4 and negative 12. 6 and 8, negative 6, negative 8. So of my list here, I want the pair that adds up to a negative 19, which is going to be negative 3 and negative 16. So that pair right there. So now I'm going to do the reverse box method. So I'm going to do it up here so I have some room at the bottom. And I'm going to make a 2 by 2. 2 columns, 2 rows. In this top column, I'm going to put my x squared term. So in my original, I have 4x squared. So that's going to go here. Then my constant is going to go in my bottom right. So that positive 12 goes here. This negative 19x is getting split between these two boxes, and that's why we had to find our factors here. I can split negative 19x into negative 3x and negative 16x. So that is what is going to go in these boxes. And it doesn't matter if I put my negative 16x here and negative 3x here and flipped them, that would be completely fine. What I'm going to do now is from every column and every row, I'm going to pull out the GCF. So I'm going to start with the columns. So for this column, whatever is next to it, I have to match the sign. So if this is positive, this is positive. So between 4 and negative 3, well, that GCF is just a positive 1. And then from x squared and x, I can pull out just 1x. So that's my GCF of that column. I move over to my other column. I have negative 16 and 12. So if this is negative, since it's right next door, I have to pull out a negative. Between 16 and 12, the biggest number I can factor out of those is going to be 4. And then they don't have a variable in common, so I can't factor that out. So I'm done with my columns. For my rows, I'm going to do the same thing. So from this side, this next door neighbor is positive, so it also has to be positive. Between 4 and 16, I can factor out a 4. And then between x squared and x, I can factor out an x. For the bottom row, if this one's negative right next door, it also has to be negative here. So between 3 and 12, I can factor out a 3. And then they don't share a variable, so I cannot factor out a variable. What we just found in the red pen are the factors, how we would write it in factored form. So if I take my top, I would have x minus 4 in one set of parentheses. And then I take my side, I have 4x minus 3 in my other set of parentheses. If I'm solving it to determine my roots, I set each of these equal to 0. So I'm going to say x minus 4 equals 0, 4x minus 3 equals 0, and then I solve those to find my roots. I solve this one, I get positive 4. And then for this one, I get positive 3/4, or we could say 0.75. So this is where our graph would cross our x-axis if we graphed it. All right, we're gonna try the one on the right. So for this one, again, I want to first look to see if I can factor out a GCF. I have 6, 4, and 10, and I know I can divide all those by 2. So I'm going to actually write it to the side so I have more room underneath because I kind of ran out of room here. And then I want to look at my variables, and it looks like I have one x in common. So when I divide this out, I would get 3x squared minus 2x plus, nope, that's a minus sign, minus 5. And I'm writing in pen. Well, that didn't really help because my a value is still not 1, so I'm going to have to factor it using the method we did on the left. So I'm going to make my t-chart. I want numbers that multiply to my a times c. Well, my a is 3 now because I'm looking at what's inside the parentheses, and my c is negative 5. When I multiply those, I get negative 15, and it has to add up to a negative 2. So factors of negative 15, if we're multiplying to a negative number, they have to be opposite signs. So one's negative, one's positive, one positive, one negative. Of my list, the pair I want is the bottom one because it adds up to my negative 2. So I'm going to make my 2 by 2 box. In the top left is going to be my 3x squared. And my bottom right is my negative 5. My negative 2x is split between a positive 3x and a negative 5x from our factors. And then I want to pull out the GCF from every column and every row. So this is a positive x, and this one is going to be a positive 1. I'm just going to put a plus sign in front. This is positive 3x, and this is negative 5. And the reason this one's negative is because its neighbor is negative, right? Positive because the neighbor is positive. So then if you want to skip this part because we're just solving for roots, you probably can. The only thing here is our GCF is 2x. So technically, we would have this as our factored form. And then since our GCF actually has a variable, we want to set this equal to 0 as well as each of these. So I'm going to skip that step and jump right to what our answers would be. If I set 2x equal to 0, I would have to divide each side by 2. I would get x equals 0. The middle one, if I set this equal to 0, I would subtract 1 on both sides. I get x equals negative 1. Then I set this one equal to 0. I add 5. Divide by 3. I would get x equals 5/3. And I'm going to leave that as a fraction because it would be a repeating decimal, and that's not as accurate. So these are going to be my roots for that one. If you would like to pause the video, you can. I'm going to go through the U-tries. So for this one, I don't have a GCF other than 1. So I'm going to make my t-chart. A times c, so 2 times negative 6 is negative 12. That add up to 1. So if it's negative, I can do negative 1 and positive 12, positive 1, negative 12. Negative 2 and 6, 2 and negative 6, negative 3 and 4, 3 and negative 4. If it's adding up to a positive 1, I want this pair right here. So I do my reverse box method. My first term, my last term, and then my middle term is split, so I have negative 3x and positive 4x. So I pull out my GCF for each column and row. So I have x plus 2, 2x minus 3. So I would get x equals negative 2, and then x equals 3 halves, or 1.5. For this one, oops, I keep grabbing the wrong pen. I noticed that my GCF is actually 6, so I can factor that out first. Maybe that'll make it easier. And that actually does, since my A value is now 1, I can make my t-chart numbers that multiply to negative 8 that add up to negative 2. Well, that's nice because I don't have to do the reverse box method. I can factor it how we would normally factor it. If it's adding up to negative 2, I want that last one there. So I would have 6, x plus 2, and x minus 4. I break them apart, set them equal to 0. I get x equals negative 2, and x equals positive 4.